We're talking about transformations. It turns out that you can do several transformations, one after the other. And when you do that, you're actually getting a more complicated transformation. If you put them together, these are actually called compositions of transformations. Let's take a look at some examples and see some really cool, surprising things when you compose different transformations together. Let's check out the first one. So we're given the triangle ABC, and we want to reflect it across the line L, and then translate it along the vector V. So here's what we've got. We've got this triangle ABC. Then we're given this line L. The first thing we want to do is take the image and reflect it over the line, which would sort of put it, I'll do it sort of informally, we sort of put it like over here, like a mirror image, and then shift it by this vector, which means I take every point and move it that far over in a direction that's parallel to that. So it would look like that. In fact, that's actually the answer. Let me just make sure that we see how we got it. So we started over here. To reflect it, remember how you actually reflect over a line really fast. Let me just remind you. For every single point, what you've got to do is you've got to find the point that's exactly opposite of that line. The way you do that is, for example, to find where A gets mapped to, the image of A, what you do is you would draw a line that's perpendicular to the line L that passes through A. So imagine a perpendicular line that goes right through it. And then measure that distance here and go that same distance here, and that tells you the reflection of A. Take the perpendicular line that's perpendicular to L that passes through C, and take the length from the line to C, and then go down that same amount. That's the image of C, and similarly for B. So when you actually do the mirror image, or the reflection, you get this. And it does isn't it sort of amazing how it looks like a mirror image? It really looks like you have a mirror there, and you're doing that. Now, to shift by a vector V, what you do is you take that vector, and you can't shrink it, you can't elongate it, and you can't twist it. So it's got to be parallel to that original vector there. But you just got to sort of put it at each of the ends, and you see where it points to. That's that point. It's sort of like that game. You have to put your feet on different colors and stuff, and then your hands. There's that point. And, oh, wait, I'm trying. I'm really trying to do this live for you. Oh, I want to do it live. I want to do it. I want to do it. I can't do it. I can't. All right, hold on. Let me try it one more time. Yeah, you think it's easy. Wait till you try your homework. All right. I'm just kidding. All right, here we go. And there you see it. So now you see those 3 points? Finger, finger, arrow. That's the shift. And if we do that for real, finger, finger, arrow, we get the answer. And so, how would I label this? Well, I'm not going to move it back. I've spent too much time. But remember, that point there goes to here. That's where the A point goes, and that got shifted to here. This is actually A prime. This B got way down here and got slid over, so this is B prime. Got to label it correctly. C goes to here, and that's C prime. And so, in fact, that is the image under this composition of transformations. Very cool. Let's take a look at another example together. They're sort of fun, I have to admit they are sort of fun, even if they are a little bit frustrating. Can't draw them. All right, so here we go. Let's take a look at the coordinate plane. And I want to rotate this triangle JKL, 90 degrees counterclockwise about the origin. And then I want to reflect it over the x-axis. All right, so the first thing we want to do is we want to rotate 90 degrees counterclockwise. And let me just remind you an easy way to do that. If you have a point x comma y, where would that point get mapped to? Well, that point would actually get mapped to negative y comma x. That's how you actually shift the entire coordinate plane 90 degrees counterclockwise. Okay, so in this context, let's see where, in fact, points would go. So let's take a look at J right here. So J, which is 3, 2, would go to negative 2, 3. So negative 2, 3. So I'm going to call this point here J prime. Now let me just warn you that things are going to get a little bit crazy. But that's J prime, negative 2, 3. Let's take a look at K, see where it gets mapped to. That's 0, 1, that would get mapped to negative 1, 0. So negative 1, 0, this point right here, I'm going to call that K prime. And finally, what about L? So we're going to shift that up 90 degrees counterclockwise, so it should probably be somewhere around here. 3 comma negative 2, 3 comma negative 2, negative negative 2, which is going to be 2 comma 3. So 2 comma 3 right here is L prime. So if we now connect those with straight lines, we're going to actually see the triangle. Now we're not done yet, because that's just the first transformation, the rotation. Don't forget, we want to then flip it over the x-axis, right? Or more fancily put, we want to reflect it over the x-axis, which means that we don't change the x's, but the y's become negative y's. So if I now want to reflect over the x-axis, what that does is it takes y's and sends them to negative y's, and the x's stay the same. But visually, it's clear, and I'm going to do it for you right now live, even though everything's going to get a little bit crazy. All I do is I just literally pick up this picture and flip it over. So you got to flip it. You got to flip it good. And that's what you look like. So this now becomes my J double prime, which you can see is negative 2 comma negative 3. Notice that this point is my K double prime, which is the same as K prime, because you see when I take that point on the x-axis and flip it over the x-axis, it doesn't change at all. So that's pretty cool. And you can see that this point right here is my L double prime, which you can see has coordinates 2 comma negative 3. Now, why am I using double prime? Well, because what I'm doing basically is I'm thinking about every time I have a particular transformation, I'll call that a prime. And so then I'm taking sort of like the prime of the other primes, so I'm calling them double primes. But anyway, that's what you can see what they look like. I should actually technically color that purple. I won't, but I'll do it here. See, now it's purple. So you can see that, in fact, there are two transformations that went on here, and when we put them together, we get this interesting composition of transformations.